Now, we talked about the FFT. Actually, the results of the FFT is exactly the same with the DFT, huh? Because FFT is just the fast algorithm calculate for DFT. And always stick into your mind. Endpoint in the FFT should follow the rule 2 power of B, yeah? 2 power of B. B equal to log N. So that also means you just say 2 point, 4 point, 8 point, 16, 32, 64, 128, 1024 on FFT. You can't say 10 on FFT, yeah? Or 15 points FFT, no. But in the DFT, yes, available. And can take arbitrary number, integer number. But and in the FFT should follow the rule to power of B. Okay. Now look the basic concept. Now the basic concept of the FFT algorithm. When we have a two, for example, when we have a two 1 point CFT, we can merge them up to make 2 points. Two points, merge them up, make 4 points. 2 4 points, merge them up, make 8 points, and so on. So that is the reason why n should follow the rule 2 power of b. Yeah, on this one. So basic merging unit. So when we have a 2, this is a zero one. If we have a 2 half n points DFT, we can merge them up to make n points DFT, right? And this is the FFT computational part. Yeah. Now, the summation index n range over both even and odd value. Okay, now we look at the algorithm of the FFT. We see this one is actually this is the x2n. We calculate for half n points of the even index, and this is the odd index values of the input signal is n. Okay, and step by step. Okay, now the summation in here. That is the proof. Now we follow the proof. Now look this one. Yeah, if we define the Gn equal to the even index of Xn, and the Xn equal to the odd index Xn. Okay. Now we apply. So when we split them up into the even and odd group, that means the length of Gn equal to Xn equal to half n. Now I have to remind you again. Yeah? The first step to calculate for the FFT, the first step for a given Xn, the first step you have to drop the signal to make the drop its signal with the length n. Okay, the length big N. That is the first step. Compulsory. And then we can use the FFT algorithm to calculate for. For example, the given Xn with the length 1000. If you want to calculate for 4 points DFT, that means the first step to do, we have to apply modulo 4 reduction. Okay, we have to apply modulo 4 reduction, first step, and then we follow the algorithm of FFT, right? Okay. The given input is 1,000, 1 million, 100,000, 5,000. But if we want to calculate for 4 CFT of the signal, we have to apply the modulo 4 reduction first. Okay? So that's it. So when we split them up into the even and odd index, then we calculate for a half endpoint DFT of Cn and Xn. Okay, this one is the half endpoint of the Cn and Xn. And step by step, we work out the result. Finally, we get this. Okay. Finally, we get this. K in this result from 0 to half n minus 1. That means the length of the xk is n over 2. Okay? Now, this is the first half or upper half of the result. And this is specified for lower half of the result. This is the proof. Okay? We can bypass, we can take time to read by yourself. I show you the result with this one on result. Okay. This is, we take the sum. We put into the upper half and we take the minus, put to the lower half of the result. Okay, now look at this one we say the butterfly merging. Butterfly merging. Okay. We have the T is in here. GK and HK. GK is the half endpoint DFT of the even index term of the exam. And the exam is the half endpoint DFT of the all index terms of exam. Okay, now we check for butterfly merging structure using this. Okay, so we have this one, the C, the H. The H we have to multiply by the zero factor WKN. Now, take this one, H to this, put to the first half. Can you see the dashed line? Split the X into two parts. And can you see the dashed line in here?
Yes, sir. Yes, sir.
Okay, good. So, if you can see the dashed line split box into the upper half, and that is, we say, the lower half. Okay? So if we take G plus this, put to the upper half, take G minus this, put to the lower half, then we get the result of n on DFT. Okay? Now, this is the typical algorithm. Consists of three conceptual parts. Shuffling the n-dimensional input into n of 1D signal. Number two, step two, performing one and one point DFT. And then butterfly merging, or we merging the n one point DFT into one n point DFT. But bearing in mind, this one just the algorithm, just the algorithm. Actually, we don't have to split the n-dimensional input into n of 1D signal. Just split it into half n of 2D signal. And then we know the result of the 2D DFT already. Do you still remember that is the result of 2 DFT, Thanh? Do you remember the result of 2 DFT or 2-point DFT? What the result come out should be? Thanh? Remember or not? Thanh?
Yes, sir. It is the sum and differences between two time sample.
Two times something. Okay, just check the sums and the difference.
Yes.
That one is 2D. Okay, 2 points DFT. So, very much easy to remember. So that means straightforward. We stop when we split the input signal, we come into the 2D signal, and then we can straightforward calculate for 2DFT, straightforward. But because this one is the algorithm, so look at this one. For example, we have that is the input is the A point. We split coupling. That is the even group. That is the odd group. Okay, specify for Gn, Xn. And split them up again. Even, odd, even, odd. And this one shows you just split it into 1D signal. But actually this one we don't need to. Practically, yeah, we can directly calculate for DFT from 2D signal. Okay, and after that, now we do the step number 3. Step number 3, merging. And 1 point, okay. So using the butterfly merging, when you can merge 2 1-point DFT becomes the 2 points DFT. Similar to this. And when we can merge 2 points DFT to make 4 points DFT. Similar to the lower group. Okay, but bearing in mind, we have to multiply every time when we do for merging, we have to multiply the results or the DFTs of the all index sums by the trigger factor. Okay, for example, if you want to merge 2 points DFT, you have to multiply this one with the trigger factor 4. 0.414, that's a half of the total student factor. If you want to merge 2 4 points to make 8 points, you have to multiply by student factor of 8. W0A, 1A, 2A, 3A. Okay? Now, Any questions about? Before I ask you, try if you get through what I did explain to you about the FFT algorithm up to now. So I give you 3 minutes to recognize the significant algorithm of the FFT supply in this example by yourself. That would be better, okay? And if you have any question, you can ask me for. Okay, try to recognize why the results come out like this. Okay? 3 minutes, in 3 minutes. It's okay? Any question? Hiếu? Hiếu?
No, teacher.
Okay. Why we have a very là anh sẽ tạo Hiếu càng tiền và hoàn cảnh thật sự. Okay. So this one we have a traffic signal. Make sure that you have to drop the signal. Match the traffic signal with the same length end. Okay? Shuffling fit into the even group and odd group. When we get 2D signal, straightforward, we can apply the results of 2-point CSC. Okay, 5 plus minus 3. 5 minus 3. Okay, this one is the sum. This is the difference of 2 time sample. Similar to this, we have a 4 minus 4. Now, we do the butterfly matching to make 4-point CFC based on 2-point CFC. We have to multiply the lower group by the two factor. This one is W04. This is W14. Okay? And now, butterfly merging, take this one, add to this. Put to the upper half, we can get 6A plus 4Z. Take this group, minus this group, put to the lower half, okay? Then we finish and get the result 4 CFT of the input traffic signal. Okay? Now, 3 minutes as well to recognize this example for the case of A-point DSP. Okay? Try, because, yeah, I forcing you for the concentration, okay, rather than I just explain to you in details about this one. Okay, I let you spend 3 minutes by yourself. Recognize the things, the significant information by yourself from the example. You can learn right now, huh? Okay. And you can remember the case. If you have any question, you can ask me for. Now, I mentioned many times the compulsory of the endpoint should be follow the rule 2 power of B. So that means N, big N, yeah? Should be 2, 4, A, 16, 32, 128, 256, 1024. Cannot be 15, cannot be 10, cannot be 9, or cannot be 6. Yeah? Just 2, 4, 8, 16, 32. That is the reason why, yeah, in the FFT, N should be follow the rule to power of B. Because when you get the values of N, big N like that, yeah, you can do the shuffling. Otherwise, you can't. Yeah. Okay, how? Okay. So the input signal just before the A, the 16 or 32. For the given original signal, the length 100. If we want to calculate for A point FFT, the first step we have to apply modulo A reduction first to make the traffic signal with the length A. Okay, and then we can apply the FFT algorithm. Any questions? Tim? Hello, Tim?
No, sir.
You understand well the procedure to get the result?
The example before,
What? You can say in Vietnamese if you want.
cái ví dụ trước này nó vẫn chưa hiểu lắm.
Now, we have a three step of the FFT algorithm. Okay? Step
Làm
one.
sao để ra số 2 vậy?
Okay. Step one, shuffling. Split up the signal into the even and odd group. Second step, calculate the DFT. Step number three, merging. Okay? So, look. That is a shuffling, yeah? We split 4 samples up into two sample groups like this, okay? Then,
Yes.
now, we know from the previous lecture, okay? The result of the 2-point DFT, just the sum, and the difference of 2 times input sample. Tức là cái kết quả mà chúng ta nói ở trong cái phần trước rồi đó. Để tính 2 điểm DFT này, thì cái kết quả nó rất là đơn giản. Chỉ lấy cái tổng của hai cái mẫu này với lại cái hiệu của hai cái mẫu này. 5 cộng cho trừ 3 là 2. 5 trừ cho trừ 3 là 8. Ok?
Dạ vâng, còn cái thứ hai tại sao nó lại là 1 với trừ chay vậy?
1 trừ chay là cái trigger factor W04, W04, W14. Đây. Đây, chúng ta phải nhân với lại cái, tức là chúng ta phải nhân cái nhóm của cái chỉ số lẻ đó, hay là nói ngắn gọn là ở cái hộp bên dưới đó, nhân với lại cái giá trị trigger factor nhé. Đây.
Dạ.
Đây là cái kết quả của cái này. Đấy, công thức này nhé.
Dạ vâng.
Đó, công thức tức là phải nhân với lại cái nhóm dưới này. Cái nhóm này là nhóm tính DFT cho cái nhóm lẻ, nhóm chỉ số lẻ, phải nhân với trigger factor. Đó, phải nhân. Sau đó chúng ta dùng cộng trừ, chúng ta mới dùng cái noodle, cái sơ đồ butterfly. Đó. Thì ra chúng ta phải nhân cái này với lại W04, W14. Đó. Đây hợp nó lại, lấy cái này cộng với lại cái box này đặt vào cái nửa trên, lấy cái này trừ cho cái này đặt vào nửa dưới, vậy thôi.
Dạ vâng, cảm ơn thầy.
Similar to the case of A point, yeah? We do the shuffling first. Okay, we do the shuffling until we get 2D signal like this. And then we start to calculate for a 2-point DFT. We don't need to split up into 1D signal, no. Yeah? But the algorithm just follows, so that one just the algorithm. But practically, yeah, we can straightforward calculate for DFT when we got 2-point signal or 2 sample signal. Okay? Now, result of this one for 2 DFT. 4 plus minus 1. 4 minus 1. 2 plus 3. 2 minus 3. Minus 3 minus 2 minus 3 minus 2. 0 plus 1. 0 minus 1. Okay? And this one we have to multiply the trigger factor W0414, W04, W14. Okay. And after we do the butterfly merging, take this one, take to this, put to the upper half. Take this minus this, put to the lower half. Similar to this. And then when we have a 2 4-point DFT, we can use the butterfly merging. bear in your mind the lower box or the old index group. We have to multiply by the factor. W0A, W1A, W2A, W3A. Okay? And then we use the butterfly matrix. Take this one, add to this, put to the upper half. Take this one, minus this, put to the lower half. Okay, everyone? It's okay, Hill?
Yes, teacher.
Now, this is the inverse FFT. Now, any of you can remember how many formula we can use to calculate for the inverse DFT or FFT? Okay, so, okay, now, firstly, yeah, I try to remove it. How many methods or how many formula we can use to calculate for endpoint DFT? And
There are three methods, sir.
forward DFT.
There's three methods.
With forward DFT.
Yes, sir.
How many formula we can use to calculate for?
I think it's three, sir.
And how many formula we can use to calculate for inverse DFT or RFT?
Maybe it's two.
What are they? Forward just 2, inverse 3, forward DFT or RFT. We can use the metric form or discrete form. But the inverse, we have a 3 formula. 2 are metric form and 1 in discrete form. Yeah. This is the inverse DFT. Okay? We have a 3 formula. This is the first formula. Now, try to have a good concentration. Yeah? I will ask you again about it. The first formula to calculate for the inverse DFT or RFT. Yeah? It doesn't matter whether we write out in here DFT or RFT. Okay? The first formula. This is the second formula. Both of them are in metric or in metric form. Huh? They are in metric form. 2 metric formula. And one more. It is a discrete formula. Okay? Now, remind you again. We have a two ways, or just say two methods, it's no problem, or two formula we can apply to calculate for the forward DFT. The first one is the discrete form, and the second is the matrix form. But the inverse DFT or FFT, we have a three formula, one discrete form, and two matrix forms. Okay? So, I remind you otherwise. Okay, now the matrix form of DFT, we have the matrix form and discrete form. Yeah? How about the inverse? The inverse, we have this is the first formula. Okay, now the first and the second. And the third one, use the DCFT. Okay, the discrete. Okay, just what I write down like this. Okay, we have a three formula to calculate for. This one, and this one, four. Always bearing in mind, we can't get back the original signal event, huh? Except the traffic signal. The traffic signal. So we have a three formula. Now, there is a question. Now, what's the formula we use in here to calculate for a point inverse FFT in this example? Just say 1, 2, or 3. How? How? What's the formula? 1, 2, or 3 we apply in this example? Yeah.
Yes, sir.
What is your answer? Hurry up.
I think it's 2, sir.
And
I think it's number 3.
number 3. Tiến.
I think it's number 2, sir.
Số absent nhé. Bánh absent. Tiến.
Number 3, sir.
Hiếu.
Number 2, sir.
Khang. Khang.
Yes,
Khang.
I'm here. Yes,
Turn on the camera.
already.
Okay. What is your answer?
I don't know, sir. I'm trying to think. 2.
Why? Why number 2?
Just get that because I don't have it. I have not think
Okay,
about the
fine.
answer yet.
Bạn biết why? Why?
Yes, yes, yes.
What is your answer?
I think it's 3, sir.
The answer should be number 2, no? Because when we look at this one, we can easy to recognize. We apply the FFT algorithm again. So look structure, yeah, we do the FFT algorithms again. So it should be number 2. Yeah. We can write out DFT or FFT, no problem, yeah? Okay. So when we look at this one, yeah, it's straightforward. Yeah, we should better recognize. Actually, we apply that is the FFT algorithm here. Now, Huang, where are you, Huang? Oh, sorry, Vic.
I'm here, sir.
Okay. This is the final result or not?
Yes, I think this is my final result.
Okay. Han,
Yes, sir.
this is the final result of the 8-point inverse FFT.
I think it's no, sir, because we will convert it to the even and odd based on the even and odd rules again.
Hiếu,
Yes.
this is the final result of the 8-point inverse FFT in the case. Here.
Yeah. I
This is
think
the
it's the
final.
final. Is it the final? I think so.
No. The final one we have to get this. Okay, we take the inverse. The final should be this. Not this one. This one we have to divide it by n. Okay. I try to put this one, ask you to check, to make you to be, to have a good concentration when I raise the question. Okay, because this one we follow the rule to calculate for LFTs again. But not yet is the final result. The final result we have to divide it by n. Huh? Okay. Any questions about this? Before we move to the chapter 9. Hurry up. I get a cup of tea, by the time, you can see raise the question if you want. Any questions? Hmm? No questions? Okay. So we move to chapter 9. Huh? Okay. Now, in the chapter 9, we just try to represent a digital filter. Okay, instead of we put on the formula specified for the relationship between the output and the input signal. Now we can use there is a figure. Okay, we use a figure or a graph to represent the relationship between input and output signal. And in this one, I split up into the chapter 9a and 9b. 9a, we talk about the block diagram. We use the basic elements, gain, delay, header. In the 9b, it is 9a, it is the 9b. In the chapter 9b, we talk about the signal flow chart. Okay, actually, yeah, we can use one of the two methods to represent for a digital filter. What's the significant reason why I put them in the chapter 9a and chapter 9b? Because some author, when you read books, some author, they just use a block diagram. But the author, they use a signal flow chart. They define for same system. But I should put in here for you, so since then, you can read any book, you can recognize well what the relationship between the input and the output when the author using the block diagrams or signal flow chart to represent for the system. Okay? Now, and general, we have a 5 forms, okay, or 5 structure. We can you in the even in the 90 or in the 90. They are direct form 1, direct form 2, or canonical form. Parallel form, cascade form, and transpose form. Okay, we have a 5. So, direct form 1, parallel, and transpose form. I believe we did get the basic concept about the direct form 1, parallel, and transpose form in previous chapter. In chapter 5, chapter 6, we would know this chapter 4 of chapter 5. We would hear about the direct form 1, parallel, and transpose form. Now we go into the details. Generally, we write down the excess is the ratio of numerator and denominator polynomial, like this. Or you can take note. You can take note. The IIR, we have a dz, but in the FIR system, dz is a constant. That means no pole in the FIR system. Only pole happens in the IIR system. Up to now, I believe when I talk about the FIR and IIR, you would recognize what are they. Han, can you say again what the FIR and IIR system? Just provide the keynote.
It has the finite numbers of sample.
Finite number of filter coefficients. Or finite number of coefficients. Okay. And IIR
has infinite number of
infinite number of filter coefficients.
Yes.
Or infinite number samples of the impulse response. Okay. So now we can easily recognize these multiplier sums fitting forward, and it's dependent because we can put out those. This one equal to y z over xz. If we take the cross multiplication and take them back the time domain, we can get the IO expression. Yeah? Are you familiar to this one? Still?
Yes, teacher.
Okay. Because we can write out this one equal to yz over xz. We take the cross multiplication and then bring it back the time domain. We can get the IO expression. Now, this one we define for the second order section. Depending on the order of the nz and the vz, we just pick up the biggest power, of course, in absolute value. The biggest power of the nz or vz, that one specified for the filter order.
Okay. I don't see the screen.
Sorry, sir. You didn't share the screen.
Why up to now you let me know about Prof? Okay. Try to ask me, show the slides anytime. Okay. Why up to now you mentioned on this one? Okay. So because we are online, so just try to let me know in the case if we got any problem related to the communication link. Okay. All right. So now this is xz equal to nz over dz. Okay. Or we can write out equal to yz over xz. If we take the cross multiplication, we can see v coefficient, they are feeding forward and it's dependent because multiplied by xz. And a multiplied by yz, so a multiplies on feeding back and y dependent. Okay. Now, second order section, we can define for pseudo order by just take the biggest number of powers, even it happens in the nz or the dz. For example, nz order minus 3. Okay, I just say for short, I just say order 3. Okay, or power 3. So you should better understand power of minus 3. We just take the absolute value, For example, nz with the power of 3, but the dz power of 5. Then we make the conclusion it is the fifth order pseudo. But in the case of nz order 3, power of 3, but the dz power 2. Then we make the conclusion it is the third order pseudo. Okay? So just pick up the biggest number of the power. So this one is the case of second order IIR. That is a direct form. Direct form. We can easily to work out for the relationship or the IO equation. Specify for the relationship between the xn and the yn. And I define this is the input circuit because depend on the input signal. And this is the output circuit, depends on the output signal. Relatively, relatively. Actually, the output yn still depends on the input circuit as well, but relatively. If we take this one is the center, we can get this is the input circuit, and this is the output circuit. Okay. So the general one, we have L, M. And we skip, this is the direct form one. Okay. Now, this example, nz order 3, dz order 4. So we have a fourth order digital filter or fourth order system. Okay. Now we can easily to write down the IO equation. Bear in your mind, I remind you again. It's no problem when we write down n-3 like the subscript of it, or we can put it in a round bracket. Okay, they are the same meaning. When we take this one equal to yz over xz and bring them back the time domain, we can get the IO equation. Two ways we can get for the plot diagram, the direct form. The first one, we can base on the illustration to check for this. The second, we can base on the exact to sketch for this. Okay, this one is seems to be easier because intuitively, we can recognize well when we sketch for the block diagram. But when you sketch this one, you can see this one was specified for the input circuit, delay 3. This is specified for the output circuit. Delay, we have a 4 delay. And this Z power of -1 in here. Okay, easy to recognize. We missed Z power of -1. 4 delay 1 sample block. But if we want to base on this one, sketch for this, you have to change the size of the position in the DZ. For example, this one is plus 0.2, we change to minus. Minus 0.3, we change to plus. Plus 0.5, we change to minus 0.5. Okay? This is, we say, the direct form 1. Now, what about the direct form 2? Direct form 2 based on the concept. Actually, this one is the specified for the NZ. And this one specified for the 1 over DZ. The concept of the direct form 2 or canonical form, we swap 1 over DZ with NZ. We swap. Okay, we swap them. Or interchanging NZ and 1 over DZ like this. Okay? So, and when we swap them, we see we have a common delay block. So we can merge them up, merge the delay block together. Okay, we can merge the delay, the common delay block. That also means we can reduce the number of the delay blocks. Okay? Instead of we have to use 4 delay blocks and 1 adder. Now we can reduce the number of delay blocks, but 1 more adder. Okay, so depending on the order of numerator and denominator, they can be in different values. So that also means we can reduce the number of delay blocks depending on the values of L and M, the order of the numerator and denominator polynomial. Okay, this is, we say, the direct form 2 or canonical form. It is a general one. It is for the second order section, namely the SOS. The general one, okay. Now, what about the cascade form? The cascade form or zero form, based on the basic concept, we split the SS into a product of second order section. Second order section or first order section or third order section, depending on the instructions. Yeah, but normally second order section. Okay, we split the excess up into the product of second order section, and we sketch each of the second order section, then connect them in cascade. For example, this one, we have a 4 second order section connected in cascade form. So that means what the filter order comes, what the order of the whole system. Viết, where are you, Viết? Viết, Viết, what are you doing? Viết, where are you?
I'm here, sir. Something.
Oh, are you
Internet connection.
Are you sleeping?
No, my internet connection. What?
Why I asked you many times? I call you many times. No response up to now. What are you doing? I think you are sleeping, huh? Tell me the truth, huh? Great. Turn on the
Yes.
camera.
I am here.
Turn on the camera. You should better, yeah, strongly recommend. Yeah, I remind you many times because you are the vice mother, so you should better turn on the camera all the time. What is your answer?
Three. I don't. 3, sir.
Why 3? What 3? Yeah? What 3? Say again, what 3? What's the number 3? Specify for what?
No.
What 3? What you mean 3? 3 specify for what?
Order.
Yeah, the order of the whole system. Why 3? Yeah, you still sleepy, I think. You still sleepy. Yeah, I know. Yeah? Okay, how? What's the order of the whole system? Look this. Now, Tiến.
Yeah,
What
the order from
order of the whole system? The whole system.
is from is0 to y3.
Here, what the order of the whole system should be? Here, picture this. Order A. We have a 4 second order section. So the whole system should be order A. Look example. We have a 2 order section. When we merge them up, the whole system should be order 4. Huh? This is now what the form of this one, Rick? What the form of this one? Hurry up, Rick.
Cascade.
And what the form of this? Hurry up. And
Yes, sir.
what's the
Is
form?
canonical form.
Canonical form or direct form third. Huh?
Yes.
Easy to recognize because the delay is blocked at the center. At the center. Sit down. Easy to recognize. It should be the direct form two, canonical form. Huh? If it's directly we sketch for system or two. But if we want to sketch the cascade form of this one, yeah, we have to sketch first one and second one, then connect them in cascade. Right? Cascade. Cascade form in Vietnamese we say ghép nối tiếp với nhau. Yeah. For example, we have order A, order 5. Yeah. Pseudo order 5 like this. Yeah. We find out the zero and the pole, and we have two conjugate poles. We merge them up to make second order. Finally, we can describe the exact by first order IIR, second order IIR, first order FIR. Oh, sorry, second order FIR. Huh? IIR, IIR, FIR. We sketch this, and sketch this. Select them in cascade. We get the cascade form of the whole system. Is this okay? Another example, order A. We split them up into 4 second order sections. Then we have the result like this. Okay? It is the order A. We split them up into 4 second order sections. If we want to describe or represent in cascade form, we sketch each of them and then select them in cascade. Okay? And you can directly sketch the original transfer function. Looks very much compact compared to the case if we want to get the cascade form. Okay? But anyway, depending on the instructions of the question, if the question asks you to provide the cascade form by using the second order section, you have to do like this. Okay? Otherwise, yeah, you can directly get this transfer function. Quicker, faster. You would raise the question why we have to split them up into the second order section, because this is quite convenient for you when you write out or when you design the digital filter. Okay? Particularly when you write out a program. Every time, yeah, you can put the second order section as a subroutine by changing the filter coefficient. Every time you can call the second order section subroutine, then you can do a for high order digital filter. For example, if you want to design for fifth order system, you can call 2 times second order section and 1 time for first order section. put them in circuit. Okay, now this is the 9A. And let's know diagram 1, 2, and chapter 4 about the parallel and transposed form. Yeah, I moved to the chapter 9B because, yeah, we have a similar concept except different steps. Okay, now the 9B. Structure for discrete time system signal flow chart. Okay, now in the block diagram we use the either the gains or the multiplier, the delay block. In the concept of the signal flow chart, we just short-circuit all of them and put the coefficient together with the mean. Okay, that means we don't have to sketch for the rectangular box like this. Just directly sketch pass through and put z power of minus 1 as the link or the line coefficient outside. Similar to this is one as well. You have to draw a circle. Just put the node in here. Okay, just put the node in here. So, see, you have this is the block diagram. What form can? What form
So
of this?
please share your screen and share
What
your.
form?
I cannot see your screen. I can.
Sorry. Just let me know as soon as possible, huh? When I change the slide. Sometimes that's okay. Okay, so this one, error, gain, delay block, we use in the block diagram. Now, what's the concept of the signal flow chart? We just short circuit. Make this one become to be a dot defined for a node. This one we bypass already, and this one we bypass. We don't have to sketch for the rectangular box. And set z power of minus 1 outside, specify for the coefficients of the line. Okay. Now, what the form of this sun? What the form of this? Hurry up. What the form of this?
This is
Where?
Yes, sir.
What the form of this?
Let me see. Canonical.
This? What the form of this?
I think it's interchange something.
Hmm?
Canonical form.
How? What the form of this? How? No, this is the direct form. This is the direct form 1. This is direct form 1. The delay is not located at the center. Should be the direct form 1, huh? Okay. Now, if we want to sketch for the signal flow chart, we just short circuit the box. Okay? We don't have to sketch the rectangular box. and put c power of minus 1 as the factor of the line. Put it downside. And this one, you don't have to sketch the circle. Just a note. Just a note. Okay. Now, signal flow graph. We define the node name and we build up the system equation. Okay, now listen to me. Yeah? This is very much important. Normally we use the signal flow chart in the case of a complicated system, not with the standard one. Okay, that means intuitively we can't straightforward write down the I/O equation. But in the block diagram, easy. Yeah? In the block diagram, we can easily write down straightforward. We can write down the I/O equation. But normally, not for the case of signal flow chart. Signal flow chart, normally we can use to represent a complicated connection of the system. Okay? So that also means we have to define the nodes and write out the node equation. After that, we solve the system equation to find out the I/O equation within the node. Okay, now how can we build up system equation? Okay, now we put the name, we define the node name, any name you want. We define this one, W1N, W2N. This is a sing, this is a source, and this is a signal. Now, this is the rule, listen to me. If we want to write down for a node equation, W1N, just take into account for the input flow signal. Just go into the node. We take into account in the node equation. This regards about the output, okay, the output or the out signal flow, like this. Okay, so look at this one. We have a 3 input, 1, 2, and 3. Then we can write down W1N equal to Sn A W2N plus B W2N. Okay, we have a first. Similar to W2N, we have just only one input range. So we can work out W2N equal to C W1N. Disregards about the output one. And similar to the Yn, we have a 2 input. So we write out Yn equal to D Sn plus E W2N. We solve the system equation. Finally, you can work out the I/O equation specified for the relationship between Sn and Yn. Okay. So this one, what's the form of this one, Bathan?
This is canonical form, sir.
Canonical form, easy. Okay, we change to the signal flow. We get this. Okay, we get this. Just start second and define nodes in here and put the c power of minus 1 is the frame coefficient of frame factor. Frame factor. Okay, now we write down the node equation. In this case, actually, we can intuitively write down the I/O equation. Still a standard form, but now how we can write down the node equation? For example, W2N, just only one in. W2N equal to W1N. How about W4? We have one input extra. We can write out W4n equal to W2n minus 1. One delay. Okay? W3n equal to B0 W2n plus B1 W4n. So we have a system equation. Then we saw a system equation. We can find out the relationship between yn. Okay, now look this one. Single flow. Okay, so we define 4 nodes like this. Now you can put down the node. When you write down the node equation, you can write it in the time domain or in the z domain. Because we have the delay. For example, this one we have that is a delay 1 sample. If you want to write down the node equation for W4 in the time domain, so that means you have to take the input delay 1 sample. Otherwise, you can write down in the z domain. W4z equal to z power minus 1 multiplied by W2z. Okay, so this one we write down in the time domain, or we can write in the z domain. Finally, we can work out the relationship between yz with the xz. We take it into the time domain, then we can get the IO equation. Okay. Now, because online I do not really know what happens with your emotion about. So I do not really know all of you. Yeah. So in the class, I can easy to recognize the emotions of your face. So, and I can guess whether you understand or you have a good concentration on it. But not in this case, except some specific students when they turn on the camera. Okay, for example, we write down the node equation of W. Tan, can you say what's the node equation for W4? Hurry up.
It is
The node equation.
W3 n minus 1.
Yes. Or in the z domain?
It is z minus 1, g power minus 1.
Say yes. The node equation of W4 in the z domain.
W4. It is z power minus 1 W3z.
W4z equal to z power minus 1 multiply W3z.
Yes. W3.
Wait, hurry up. What's the node equation of W3? This. Yeah, I know. This is slipping. So, okay. How? Okay. Or in the time domain, W3n equal to in time domain. Same time domain. That one is in Z domain. What about in time domain? Say again, how? What the W3Z equals to? In Z domain. Okay, now what about in time domain? In time domain, in the time domain, trong miệng thời gian là làm gì có gì ở đây? Đó là ST gì? In time domain mà. Say again đi. Say again. Thì đây đang ở district signal mà. Làm gì có thi ở đây? Phải là em chứ. Em đang nói về district time system mà. Trời ơi, hurry up thôi. Thôi. Okay, direct form 1. Direct form 1. Similar to the case of block diagram, yeah? Direct form 2 as well, except we just short-circuit all the box. That's all. Okay. What's the form of this one? Hiệu? Hurry up.
Ơi, em đang bị viêm họng.
Okay. This one should be direct form 1, huh? It is direct form 2. Okay. Similar, we get the cascade form. Cascade form. Now, Toan, where are you, Toan? Toan, đang biết Toan.
Yes.
Turn on the camera.
I already turned that camera, but I think.
Can't see you. No.
Oh, it.
Okay. No. Okay. What's the order of the whole system?
So you can repeat it. What's the?
What's the order of the whole system? Now, Cha Quốc Khang. Where are you, Khang? Hurry up.
I'm here, sir.
You run out of time. Yeah. What is your answer?
I don't know.
Nguyễn Kim. Nguyễn Kim.
I'm here, sir. Can you see me?
Not yet. Not yet. Turn off the camera, Khang. You can turn off the camera. Okay. Where are you, Kim? Fine. You can turn off the camera. Okay. Fine. Turn off the camera. Where are you, Kim? Hurry up, Kim.
I'm here, sir. Do you see me?
What is your answer? Yeah.
I think 3.
Thanh. Bác Thanh.
It's 2, sir.
Should be 6. 3 second order sections, so whole system should be 6. Right. Surprised about that, yeah. Most of you are still sleepy, I think. Still sleepy. So you have a not good concentration. Okay, take care of yourself. Huh? I can't find forcing the example. What's the noise?
So
Please,
fine. Turn off the microphone.
turn off the noise.
Ah, yes.
Okay. Look this one. Yeah. We have a second order section. We split them up into the first order sums like this. Okay, and then we split them up into 2 parts. We sketch each of them. Direct from one of the second. Put them in cascade form. Okay. Or we can write down to the cascade form by using direct form 2 or canonical form. This one, sketch for this. This one, sketch for this. Put them together in cascade form. Huh? Parallel form. Cascade form, we split the transfer function up into a product of multiple subsystems. How about the case of parallel form? We split the transfer function up into the sum. Okay? The sum of multiple subsystems. Okay? Cascade, a product. Parallel form, a sum. Okay, so transfer function, we split them up into a number of subsystems by using the sum. And then we can sketch each of them, then connect them in parallel. Okay? Now, Kim, where are you? Hurry up, Kim. What
I'm
is
here,
the
sir.
form of this one? What's the form of this one?
I think it's parallel.
No, what's the form of this one? See, can you see your mouse?
Cascade.
No. Toàn. What is the form, Toàn? Hurry up. Look at the moving of the mouse. What a form. Hurry up. Thanh. What a form.
This is conical forms.
Canonical form. What? This.
It's also canonical.
Okay, canonical form. Okay. Connect them in parallel. Huh? Okay. For example, this one. Second order section, we split them up into 2 sums like this. If we sketch 2 sums, connect them in parallel. Or we split them up again into the first order sum and sketch them in parallel. Okay, now the left hand side figure, we try to sketch the parallel form by using second order section. If the question asks you to do 4. But if the question asks you to provide the parallel form by using first order system, then you have to get like this. Yeah? Understand what I mean? Tức là tùy theo cái câu hỏi. Nếu mà câu hỏi bắt chúng ta dùng những cái bộ bậc 2 thì chúng ta phải vẽ như thế này, không kể hàng số nhé. Nếu mà đề bài bắt chúng ta phải dùng các cái bộ bậc 1 thì chúng ta phải vẽ như thế này. Another form. Okay? Okay. Sit back. Okay? Just a sample. Now, significant one is the last one. Huh? We already did 1, 2, 3, 4, number 5. Now, listen to me. Huh? Just a rule. If we want to sketch the transpose form of the system, we can base on the direct form tool. Direct form tool. Huh? Use the direct form tool. We swap. That is, that is the right hand side circuit, left hand side circuit. We interchange. Take this one to the left. Take this one to the right hand side. Then we have a transpose form. But you have to mention on the direction. Now, this is a rule. You can put out the note. Yeah? With the horizontal node, horizontal branches, the direction of the signal do not change, but we change the directions of the vertical line. For example, we take this one to the left. We see with this branch, the signal going from right to left. Left to right. Still keep left to right. Left to right for B1, B2 as well. Keep the same direction. But look, the vertical line. Okay? The signal flows from bottom to top. Okay? Bottom to top. We change to top to bottom. Right? And the center as well. From top to bottom. We change to from bottom to top. Similar to this one, from bottom to top. We change to from top to bottom. Okay. Do any of you have already the next online lecture? Any of you?
Yes, I have the online.
Okay. Quickly, yeah. Okay. Remember, so this is the last one I want to say to talk to you. Tức là cái transpose form chúng ta có thể vẽ, chúng ta căn cứ trên cái hình của direct form tool đó, chúng ta mới hoán vị cái khối bên phải với cái khối bên trái, và theo cái quy tắc như thế này, giữ nguyên cái chiều đi của cái tín hiệu đối với những cái đường nằm ngang và đổi chiều những cái đường nằm dọc. Thế thôi. Okay? Can take note. Okay. That's all I want to talk to you. Now, this one just provide you some concept about. Yeah, we don't need to. Any questions? Hurry up before I just say something very short about how can you review for. You know the final exams already, yeah? And
Yeah.
What the final exam? What the days of the final exam?
It is on. Let me check. It's about the
Not about.
18 December 18.
18 or 14? 18?
18.
Okay. Why you take a different day with the Wednesday class? Yeah, I think it should be the same day. Yeah.
I don't know. I see it in the schedule of my BK.
Yeah. Surprised about. Yeah, it should be the same day. Yeah. On Wednesday, yeah, we got. I did not put in. Is it the same day with the Wednesday group? And you know about?
I don't know, sir.
Yeah,
I will check. I will check with my friends.
Okay. No problem. Now, for the review, yeah, you should better review from chapter 4 up to now. Huh? Chapter 4. Yeah, mostly the question we deal with the discrete time signal system. I would not ask you to calculate for the practical analog filter anymore. Huh? But I still put the sampling. I may put the sampling concept together with the discrete time signal system from chapter 4 up to now. Okay? And I may provide you some quiz questions that những cái câu hỏi ngắn quiz together with the big questions. Yeah, up to now I haven't yet figured out what the final is, but yeah, it can be so. Any questions? Fun?
No, sir.
All of you can turn on the camera, yeah? I check your attendance today. Okay, yeah, that's good. Well, are you with? Okay.
Here, sir.
Okay. Thành Kim Trung Áp Thành Tâm Áp Thành Tiến Việt. Turn on the camera, Khang. Tao Phúc Khang. Where are you? Any question, Toàn? Okay. It's not.
Thầy ơi,
See?
bạn Khánh bạn bị Covid này.
Ồ, vậy hả?
Dạ,
Ở đâu mà bị? Ở tỉnh
ở
nào?
thành phố rồi.
Ồ, ở quận mấy?
Như ở Tân Bình hay gì, con không biết nữa.
Ừ.
Tại nhà con Bình Dương.
Rồi bạn Khánh bảo hả?
Dạ.